Hello and welcome back to the coAdjoint video development blog. This is video number 3 in the series. If you miss 1 or 2, then please feel free to click on the links on the right hand side. In this video I'd like to wrap up what we were dealing with in the previous ones and just show a little bit of the back end of our new features and how a developer would actually implement them in their software. Now bear in mind these are only prototypes at the moment, but we're working on getting the full functionality, the full graphical user interfaces for them ready as we speak. So in the demo we saw that we had a skill allocation screen, and that showed all the skills that affected the game. Now something that I spoke a little bit about on my last WordPress blog post was that the thing that differentiates our model from different ones is that these skills are actually dependent upon each other. Now this is in contrast to a game like Oblivion, where skills aren't dependent upon each other. So if your one-handed sword skill is 100, that doesn't mean that your two-handed sword skill is going to have, it could be 0. And in real life, skills don't work like that. There is some transfer between related skills to each other. And that's what we've actually been able to mathematically model. And that's the real strong feature of our system, in that you can build up sort of a network of related skills. And I can actually show you the network that we've built for these skills. So each node on the network represents one particular skill, and a line going between two skills shows that there's assumed to be some sort of functional dependence between those skills. Now I haven't got the weights on this diagram, but by the weights I mean the strength of that dependency between the two skills. Now to define that strength you need two numbers, because if we call this skill 1 and that's skill 2, then skill 1 might have an effect on skill 2, but skill 2 might not have an effect on skill 1. So you need two numbers to define the two-way relationship between skills. Now on our network there are some very general skills like strength and speed, and some very specific skills like the amount of wobble that you get on a sniper rifle. And I think that sort of interplay between quite general skills and quite specific skills can create some quite dynamic and complex actual gameplay mechanics, and that's what we're really looking for. I think this opens up a lot of possibilities for users of a game to customize their character to something really specific, based upon solely the way they play the game, if they're good enough at doing it. So I'd like to think that our model actually builds up new possibilities for gameplay and new options, for example in first-person shooters, for tactical behaviour in multiplayers. So next I'd like to show you how this relationship actually feeds into our adaptive AI systems. The adaptive AI actually considers this network when it makes its decisions about how to deal with the player. And to demonstrate that, I'm going to show you our prototype for the adaptive AI training. Now the way that we actually do our AI at the moment is by giving the computer training examples, and then from those training examples, say if you gave it 50 training examples, I'll show you exactly what a training example is in the moment. It's actually able to intelligently deal with any training example, any user's skill set, because it has a wide enough range of data to deal with that it can actually sort of interpolate between skill sets and decide, okay, it's likely that this is the best behavior for us. So to demonstrate this, I'm going to show you our prototype. Whilst I'm getting this up, I'd just like to say thank you very much to anyone who's given me any feedback so far on the Facebook page, on YouTube. It really does mean a lot to me to know that people like what I'm doing. So if you do like what you see, then please leave me a comment or give me a like on the video, or subscribe to my channel, because this gives me a lot of sort of positive reinforcement that what I'm actually doing is useful and people like my ideas. If you don't like what I'm doing, then I'm more than willing to discuss it with you, but please try and keep it constructive. Anyway, so this is our prototype for the AI development system at the moment. It might seem modest, but we do actually have plans of how we're going to extend this to make it a fully fledged product. But this is how we did it for our demo so far. Now, what you see here is one training example, and this represents one user's potential skill set that he could have picked when he allocates his screen at the beginning of the demo, which we see here. So each of these entries into the grid represents one skill, and each of those skills is given a number, just like you would assign on the skill allocation screen here. Now also for each entry on the grid, each skill, we see a colour, and that colour represents how high the skill level is. And there's a reason why we're using colours, because to make this training, this teaching process for the AI simple, to teach our AI what to do, we think it will be really useful to do this all graphically, so that you don't get caught up with individual numbers. You more get a feel for the actual skill set of the user, rather than dealing with each individual number. It's much easier and much more intuitive when you can just deal with a picture. And so that's the basis of our heat map system, which is why it's called heat. So red areas on the network actually represent hotter areas of that skill. So you could look at this heat map. This is what we call it, a heat map, for the red and blue areas on the skill overlaid over the skill network. You could look at this heat map and you say, okay, he's red around rockets, he's red around throwable grenades. And if you knew your network well enough, you could say, okay, I know how I want the AI to deal with this. And you could say that what you do is, once you've decided how you want it, you assign that to a classification. And what I mean by a classification is that number, your classification, represents how you're going to program up the finite state machines and all the other bot features that are done in standard games. But each classification is slightly different from the other, because it's dealing with adaptively with different skill sets of the user. So another skill set, another heat map that you could see, would represent a completely different user, and so a different classification might be more suitable than the one you chose for the previous one. Now, it's not to generate these examples, these training examples, we don't just generate random numbers. This is where the network comes into it. So I'll flash it up again. Because skills are related, it doesn't make sense just to randomly assign numbers, because then you wouldn't see any patterns within the skill network. So if the rocket reload skill was 72, for example, like it is here, and then his rocket run skill was 30, that wouldn't make sense, because how could his rocket reload skill have gotten so high unless he's really manipulating the model very well? So this is another feature of our training software, that we generate these numbers, although it's like pseudo randomly. We actually consider the network as well, and that's part of the detail of our training process. So not only have we built the AI to teach, but we've actually built up the training software as well. And that's basically it for the moment. We deal with lots of different examples of these. We assign a classification in the screen here. Just give it a number, say for example 2, and then it will go on to generate another random example, pseudo-random example, which represents another user skill. We're given another classification, and then in the game, when it comes across any example of any skill set, it can say, okay, this is sort of similar to this sort of skill set that we've seen before. It's quite likely that we should choose this classification, and that's exactly what you saw in the demo. It takes the skill set. Oh, that's my Unity code. It takes the skill set you see here, it gives it a classification automatically. This is not one that it's seen before, but it knows how to deal with it. So that's basically how we built the back end for our demo so far. In the next video, as I said, I'm going to talk more about the actual development at the moment, and I'll probably get up Unity to showcase that. But I'm afraid that will have to come in a few more days, as I need to learn some more Unity before I'm able to do that. But anyway, thank you very much for tuning in again. If you have any feedback, please let me know. Please give me a like if you think this is useful, if you like the series, and give me some feedback on the Facebook page or the Unity thread. Cheers, and I'll see you guys soon.